Welcome to this tutorial on how to effectively implement wearable haptics for XR use cases. This tutorial is made possible by Presence, a European project of different partners where we focus on implementing three different types of technologies, namely holoportation, haptics, and realistic avatars into one SDK. Today we're going to specifically talk about the implementation of haptics. My name is Gijs ten Butter, co-founder and chief product officer of SenseGlove. In the Presence project, we have the privilege to share the Work Package 3 haptics together with our partners Razer and Electronica. Together with the CEO of Interhaptics, which is the part that focuses on haptics within Razer, Eric Vezzoli, and with the CTO of Electronica, Rafael Peweski, and myself and some other haptic experts, we've written a book on how to actually effectively implement haptics within XR use cases. So you've heard now haptics, but what is actually haptics? You might refer haptics to the digital sense of touch. But it's a little bit more complex than that. So haptics is a subset of technologies. So it's not just one digital touch technology. There's multiple technologies that enable users to experience tactile sensations. Okay, that's fine. And interactions, so also the interactions are part within the haptic definitions with digital environments. Obviously, that's logical. So then the definition continues with stimulating the sense of touch to enhance immersion, scale transfer, or realism. So don't expect a full HD display where you can actually feel everything you would feel in real life, but it's a subset of technologies to give you tactile sensations, to stimulate the sense of touch, to enhance a certain goal inside an XR environment, so immersion, skill transfer, or realism. So that said, what are actually these subset of technologies? Because basically we have, as humans, two ways, or two organs, or two methods how to perceive touch. The first one is based on your skin. The second one is based on your muscles. So within your skin, you have basically three different receptors that can convey the sense of touch. You have little hairs in your body that can distinguish little vibrations. And with that vibration, you can feel like textures, or you can feel like clicks of buttons. And to translate to technology, that is a quite known technology, I would say, from, for instance, your smartphone, where you use vibrotactile motors. And that can be like piezo elements, that can be LRAs or ERMs, everything that basically vibrates and simulate in a certain way the, tactile sensation belonging to textures or belonging to like clicks. Secondly, we feel as humans edges. And we do that by actually the amount of skin that's been stretched or pressed on your body. So there are little receptors that can distinguish the delta between how was your skin before touching and how's your skin now. And in haptics, we call this technology contact feedback. And there are different ways on how to convey that. But for instance, one is to use like little microfluidics to pump up a little bubble inside your hand, and that presses actually against your skin, and that deforms your skin, and therefore you can feel some forms of shapes. You have other technologies that actually use that skin stretch method, so they're kind of opening up your skin, widening up your skin in order to trick your brain, and that you can feel the delta between how was your skin before and now it is stretched. And then thirdly, you can actually feel temperature differences. and yeah, you can convey that in temperature feedback by, for instance, using Peltier elements. So that is the skin part of haptics. But then we also have the kinesthetic part of haptics based on our muscles. So if our muscles contract, we can actually define the stiffness of an object when you contract your finger-based muscles, and for instance, the weight of an object when you contract your arm-based muscles. And in haptics, we have basically two forms of kinesthetic feedback. One form of kinesthetic feedback is what we call passive force feedback. So you actually, as a user, exerts force on a system, and that system stops your hand or stops your body from moving into that system, and that is a fully passive. So that's a system that cannot retract your fingers itself, but it can only give a stopping force. And then if you actually have a system with motors, for instance, that can exert forces on your body, we call it active force feedback. But if you have implemented all of those technologies into one device, you're not there yet, because you have all kind of other factors that will define the fidelity, so the precision of how you feel. To start with, you have resolution. Resolution defines the steps of increasing and decreasing of the fidelity of a haptic sensation. So if you look at vibrotactile feedback, we're looking at frequency and also at the domain. So how fast can a vibromotor vibrate? So with how many hertz? And what is the actual bandwidth of that hertz? So is that between 0 and 500 hertz? Or is that a very narrow bandwidth, for instance? And obviously vibromotors have usually like a resonance frequency where they are the best. So they have the best amplitude, I'll come to that later, at a certain frequency. But the more variation you have, the more HD vibrotactile feedback we're talking about as hapticians. Then obviously if you look at force feedback, you have force resolution. So what is the increased tap of newtons that I can feel? Is that per step an increase of like 5 newtons, or is that per step an increase of 0.3 newtons? That is your force resolution. So for contact systems, you have something we call pixel displacement. So what is the actual amount of skin that can be stretched? And for temperature, obviously it's temperature resolution. So what's the difference in temperature? So like a high, if you have big steps, we call it low temperature resolution. If you have small steps, it's high temperature resolution. And secondly, we have the strength that actually determines the fidelity of haptics. So for vibrotactile feedback, that's the amplitude. So how many G-forces can that actual motor vibrate against my skin or against where I want to put it. For force, it's the amount of newtons of force that's applied. So is that like 0.5 newton? That's like a weak strength. But if you look at more advanced force feedback systems, they can deliver up to like 14 newton. So yeah, what is the actual strength that's being applied? And for contact feedback, the amount of pressure, so how fierce can this bubble, for instance, press against my skin? That's usually measured in Pascal. And for temperature, that's the temperature delta. So what is the actual difference in, so like the extreme difference that you can feel? So is that delta 20 degrees, or is that delta just 0.5 degrees? And then thirdly, we're not there yet, we have the amount of actuators, so actually pixel density, what they usually refer to. So for vibrotactile feedback, we're looking at an actuator array, so how many actuators can be steered in one go and how many actuators can be steered individually. And then for force feedback, we usually call looking at actuated degrees of freedom. So a joint can have obviously 4 degrees of freedom. It has this joint, has this joint, has this joint, has that joint. Well, usually a system doesn't actually actuate all the joints in a system. And for both temperature feedback but also for contact feedback. We're looking at touch point density. So how many of those touch points do I have on my skin? And lastly, it's not really divided over the technologies, but it's more of a system architecture, is the latency. But also in actuator choice and design is very important to know what is, for instance, my spin up time. So how fast, if I send a signal to a motor, how fast does it actually deliver my capabilities that I want from the motor, and is it able to synchronize with other systems? So can you actually make an array when you're looking at vibrotactile feedback? And then also, what's the response time in such a synchronization? And obviously you have also a system in place that has system latency. So what's the latency from your microcontroller to your actual motor? What's the system latency from your physics engine inside your headset or inside your computer environment to the microcontroller? What is the process time of the microcontroller? Everything like that you need to take into account in order to determine the latency of a system. So all in all, there's a lot of different technologies and a lot of different perceptions or methods that actually determine the fidelity of how you as a user experience haptics. So therefore, is there a way to actually build a display where you can feel like in real life? Maybe there is one day, but today, unfortunately, not. So that's also something you need to really realize when implementing haptics. You need to choose the actual purpose of your haptic implementation. Because if you don't, you'll end up with false expectations. Some other concept which is very important to understand before we actually dive into how to implement haptics. And that's what we call versatility versus specialization. So if there is a versatile simulation, or if there's a versatile experience, there is a lot of interactions that are being played or that are being demanded from a simulation. Where at the specialization part, there's usually just one very specific type of sense of touch that need to be conveyed. Or there's one interaction that's really important to convey. And obviously, if you go to a more specialized interaction, you can really focus on that particular interaction, on that particular haptic feeling. So you can make things way more realistic than when you're looking at a versatile situation where there's a lot of different interactions, because then you need to find kind of the common ground between those interactions. And then it gets more difficult to build for realism. So that's a concept I would like you to understand before actually starting. So you have heard the word interaction quite a few times now. And there is something in the taxonomy that we call haptic interactions. And basically every haptic interaction has been triggered by a collision. So haptics usually relies on a collision engine, or in other words, sometimes called a physics engine. And within haptics, you have basically two types of haptic interaction frameworks. The one is called an allocentric haptics. That is, I, as a user, initiate an interaction. So I push on a button, my finger collides with that button has been triggered to give me haptic feedback. The other way, you have egocentric haptics, where you as a user just are in an environment and the environment itself triggers haptics for you. So that can be you're in an environment and you walk through rain and it starts to rain and the rain drops down on you. Or you are just there and someone taps you on the shoulder. That's what we call egocentric haptics. And that also brings in a different type of playing of haptics. You have static effects that can be just every time you have that effect being played on you, it's the same. So, for instance, you could design a button like you push it and then a vibration has been played from that button. It's kind of a play and forget. You just always play the same signal. But within dynamic interactions, you have another parameter that actually determines the amplitude, the density, the force. So it determines any of the haptic parameters. And for instance, if you're designing textures, you're obviously patting a surface, and the actual speed where you're patting with determines the frequency of the vibrotactile signal in this case. So this is more a dynamic interaction. And also, for instance, when you pressing on a stress ball, the amount of force that you apply or the amount of delta of movement determines the amount of force resistance that your fingers are getting. So that's more of a dynamic interaction. So in designing, that's different than from a static interaction, because with a static interaction you just have one signal that plays, and that plays until it's finished, until you do have determined it's finished. Usually also in a given format, so it always plays for 1 second. And with dynamic, it's just you touch it, and then based on the velocity, based on the movement that you make, based on the speed, the parameters change. So now we know the actual framework on how haptics are usually triggered and what are the two different types of haptic sensations, so static and dynamic, that can be played. So now we can look at what type of interactions are there out there. And firstly, we can look at object-based interactions. So you as a person are grabbing or initiating an object. And usually an object-based interaction is where a interaction doesn't have any constraints. So you can just pick it up and do with it what you want. So if you have a large object, you would like maybe to have the ability to manipulate it with 2 hands. So you can grab it, you can get feedback from the object, and you can rotate it between 2 hands. You can kind of take the mean of where your hands are. You have small objects, maybe you want to manipulate small objects within 1 hand, so you can actually rotate it between your head. You have objects that are stiff, so that can have feedback based on the amount of how you actually grab it. And you have active objects that can actually also apply an effect or a force onto you as a body. And obviously most object-based interactions are relying on your interaction with your hands, unless it's been thrown at you, but we'll come later to those contextual interactions. And then you have fixed-based surface interactions, and it can be like dynamic clicks and controls, like a button that's on a position, you push it maybe with a certain velocity, and it gives you feedback. You have dynamic interactions, so as a lever or a drawer, it always stays in one place, but you can move it based on the amount of force you apply to it, based on how you grab it. Then you have things like textures, so it's there, but you can pet it, and because based on how you pet it, it gives you a signal. And then you have static interactions, those are just objects that cannot move, and you can obviously touch it, and it can give feedback back. So those are kind of the fixed surface-based interactions. Then lastly, you have the contextual interactions, where you have ambient effects. So those are not per se effects that actually collide with you, but those can be like an effect triggered by another system, like a train, and you feel the wind of that train, for instance. Or there are contextual awareness type of interactions. That is a bit of enhancement, so I'm not sure if that is like a really real life interaction, but you might, if you hear someone approaching you, if you
have an auditive cue, you would like to enhance that with haptics, so you can get more contextual awarenesses. And you have something like shocks, so that can be someone tapping on your shoulder, someone hitting you, or you've been hit, for instance, by a third-party object like a bullet. That can be more contextual interactions. So now we've talked about what type of interactions there are, what type of haptic feedback is there, and how what type of frameworks are there to trigger the feedback, and what types of sensations can I give. And then it's really time to start implementing those things we've learned. But in order to start, you really need to know what is the goal that I want to achieve with my haptic feedback. And basically, there are just 3 objectives that you can choose from. Not that many. And you need to choose. You cannot say, I want all of them. So basically, the 3 different ways, different main objectives of haptics are improved skill transfer, improved immersion, and improved realism. So if you're looking at improved skill transfer, that's really about training. It's usually in versatility of interactions. So to build muscle memory, to learn complex procedures, to learn basic skills, really focus on the interaction level. So make sure the interactions represent real life interactions. If you're looking at immersion, it's really to enhance the user experience with an external environment. So you want to get better engagement of participants. And surely it doesn't have to be realistic, but you can do everything to just suck the participant into the scenario. And then there's obviously improved realism. Usually that's with very specialized simulations. And that is really to enhance in one-on-one situation. Before we actually start design, take a look into a little bit of the tips and tricks and preconditions of haptics. So as you have set your main objective, you need to also know, okay, what type of feedback or what type of devices I would like to use. But before that, you need to know that there is like transparency in haptics, so devices that are not limiting you in any way. So, for instance, our Nova 2 haptic gloves, you just put them on, they're lightweight, you won't even feel it after a few minutes if you're wearing it. And then you have very non-transparent devices where you just tie it to a certain robot, for instance. And because you're tight, you cannot move freely, you're just stationary at one place. And that's perfect when you have like a standing, just a sit-down interaction. But when you have a scenario with more versatility in there, with more freedom of walking, for instance, you would rather go to a more transparent solution. And a good way to enhance your haptic feedback beyond the technologies are using pseudo-haptics. There are basically 2 ways of pseudo-haptics. One is fully physical and one is fully virtual. And the first one is physical, and you can just use dummies. So if you have an interaction that's very specialized, like drilling in a surgical simulation, why won't you just represent a 3D printed object of that drill and add it to a haptic pen, so it can actually give you also some vibro-tactile feedback and some force feedback based on the amount of force you apply to the unit. Another trick is to give haptic illusions. So those are tricks within your software in order to enhance the feeling of the sensations in your scenario. And good haptic illusions are, for instance, a God hand, where your hand actually physically moves through a virtual object, but your visual representation of that hand stays on that object. And then it enhances the feeling of that there is an object there where your hand been laying on. Another good way to perceive, for instance, weight is to slow down the movement of your virtual hand compared to your real hand. Your brain will think an object is more heavier than it is in real life, because obviously with wearable haptics you cannot simulate weight. And then a third good haptic illusion is kind of a self-touch UI. So if you just want to create a UI, you can, for instance, make a watch on your own wrist, a virtual watch on your own wrist. So each time you push that menu on that watch, you actually feel your own skin.
So we already have touched upon that haptics is always in an orchestra of visual and audio information. There are different ways how those multisensory perceptions can be implemented. Let's talk about the ways how to implement haptics. Haptics can be implemented to reinforce audio and visual, playing at the same time, full synchronization. So, for instance, if you are programming a mixer, this could be the way to do it. At the same time, you push the button of the mixer, you feel the mixer starting to vibrate, you hear the noise of the mixer that is turning on, and you see the rotation of the mixer, and you see the actual substance that you're mixing moving. That is a reinforced way of implementing haptics. Haptics can also be implemented as the primary sense. So you emphasize your experience based on the haptics. In a situation of rain, this could be interesting, where you feel the rain at first. Obviously you can see and you hear the rain in the background. But the most primary part can be the raindrops dripping down on your body. This is something different than when we're looking at an initial haptics. That could be, for instance, I'm patching a surface and there is a thing sticking out of the surface, and I first program the haptics, like I touch it, I feel it, and then I take a closer look, I see it, and then afterwards, or like maybe incongruent, maybe close to when you actually feel it, you have some audio feedback. Haptics can also be to complement visual and audio. If you have to complement, then you synchronize the visual and audio. So for instance, you see this button lighting up. You also hear the click that you're touching it. And around the same time, you feel the vibration, you feel the sensation of touch that you would like to convey. So in that sense, you synchronize the audio and visual, but there's an asynchronous perception of touch. You can also have a secondary way of haptics, so the visual and audio are more present. So for instance, in this case, you see an elephant running, you hear the elephant running, and then you hear the elephant making a noise and stamping on the ground, and there's a slight in the background rhythm that you can feel of that the actual elephant is passing by. Haptics can also be used as follow-up. So what I really like in a situation is what we call a confirmation completion haptics. So you have done a task, for instance, pushing a button, turning off a device, and the device is turned off. If you hear the sound that the device was turned off, and then as last, to really complete the cycle, a little confirmation like I did well haptics. That can be kind of a follow-up signal that you can give to haptics. Now, but let's actually start the tutorial. We've given you a lot of information about haptics, about like preconditions, about the different effects, but now it's your time to actually implement it. So the first thing we need to do is to define, why am I actually willing to have haptics? So what is my main objective? Do I want to use haptics to improve the skill transfer? Do I want to use haptics to improve the immersion of the player? Or do I want to just improve the realism of the environment? Well,
once you've defined what the main objective is, let's dive into the full scenario. What I want you to do is for every interaction, so think of every interaction that is possibly in your scenario and write that down in the scenario. Feel free to use AI tools to draft a more detailed picture of your interactions, but please write it down. It is a bit of an elaborate process, but it will help you also developing your game states in the end and developing the actual interaction options when you start coding. So here I just take one example of one interaction, and probably a scenario has 20 to 50 different interactions that are possible. List them all down and go one by one, step by step. So how detailed should I be? I've just made an example here based on a training to use wheel guns to replace a wheel for the change of a winter tire to a summer tire. And this is, for instance, one of the interactions that is in there, the interaction where you loosen the bolts. So the trainee stands in an auto repair shop positioned next to the car on an elevated hydraulic lift. He grips the hydraulic wheel gun with his left hand, resting firmly on top of the tool for stability. His right hand holds the handle, fingers wrapped around the bar. In the right index finger, presses down deliberately on the trigger button. For exactly 2.3 seconds, the trigger remains engaged until the first bolt is fully loosened. The trainee then eases the finger off the trigger, causing the wheel gun to stop rotating. The bolt now hangs loosely in the hole where it was once firmly secured. So that is a full description of one interaction, namely the person operating the wheel gun on one of the 6 bolts. Then when you have listed all your interactions, all your possible interactions as detailed as possible into a scenario, you have to start defining the haptics around it. First, also per step, define what is my objective. Is that skill transfer? Is that realism? Is that immersion? So in this case, obviously, it's about a training. So we see this as a skill transfer as the main importance. Then also just list the importance of your interaction. So how important is the haptics, or how important is the haptics for this interaction? We'll come to that later why. And then you can sketch the actual interaction belonging to it. So in this case, this is a two-handed manipulation because I'm holding the drill with 2 hands and I can actually move it around. And there's an active object because the drill will actually, or the trigger of the drill will actually push back. And now it's time to actually list the haptic feedback that we want from it. So probably we want force feedback from both the rigid body of the drill itself, so to handle the size and the density of that drill. And we want, well, active force feedback or gradually force feedback on your finger because you want to trigger the actual trigger of the wheel gun. And we want some vibro-tactile feedback to feel if the drill is engaged, yes or not. So now you have listed all your interactions. You have sketched your interactions. You've sketched your haptics that you want. So now list down all the actual haptic feedback technologies that you've listed down. And, well, count them. Maybe you have written down 5 times force feedback, 10 times vibrotactile feedback, 1 time temperature feedback, and also check for the importance of your interaction. So it can be that you listed down temperature feedback, but that the temperature feedback interaction is actually not one of your more important interactions. So probably due to budget reasons and due to like constraints of developing, you can get rid of that temperature interaction. But it can also be that you want to have the main objective of one interaction is realism, and you rate that interaction is really important, and you want to have contact feedback and force feedback and vibrotactile feedback in there, well, maybe then look at a more specialized haptic solution rather than something that is more versatile. In our case, with the wheel gun example and with the whole training of changing the tire, we want something that is a little bit more versatile, because we have the interactions with the wheel gun, we have the interactions with the wheel, we have the interactions with the bolt, we have the interaction with the hydraulic forklift, and so on. So, and these are all important to train. So we are going for a little bit more versatile one. And then, obviously, you want to also reconsider your preconditions, such as budget, also the transparency. Do I need to move a lot? In our case, yes, we need to walk from the buttons of the forklift to the wheel. We need to take the hydraulic wheel gun from the ground up, so we need to move freely. So there needs to be a transparent choice of device. And also throughput is high in our case, because there's a training, and there's a lot of trainees that need to be trained in a certain amount of time. So also the ease of use is important, and the ease of setting it up. Well, these are all the considerations you need to take into account before you actually select the device that you're working with. In presence, we don't have actually that amount of choice. We have the vest, we have the gloves, and we have controllers, but still it is important to convey with these scenarios in order to select the right haptic input. And then start also designing your really multisensory parts. So list down which other sensations and which other senses, obviously visual and audio, you would like to include, and also list down how you would like to include it, and what type of synchronization or what type of interaction between the multisensory parts you would like to have it. Then once you've listed this all down and you made your whole scenario, it is time to start developing. And that's quite easy from this template, because you've all listed your interactions. You also listed the order of the interactions, so you can start directly developing your game state. You can look into interactive toolkits and start matching the pre-programmed interactions with the interactions that you've listed down. And you see, it becomes an easy way of actually deploying your scenario into an XR experience. At SenseGlow, we always start first with the interactions. So build all the interactions with primitives. So don't spice up things with nice textures or whatsoever yet. Just make sure that every primitive is in there. That's also for your actual VR environment. Make sure that everything you would like to interact with is a separate body. So has its own rigid body and has its own collision or collider around it. Because otherwise it will be never possible to interact with it. Then once you've designed all your primitives and all the rigid bodies in your scene, you can test the interactions that you designed. And do that first, prior to any enhancement of audio and visual perceptions. Because the interactions is the most important part when dealing with an haptic scenario. And obviously iterate until multiple participants are able to fully complete the interactions in the scenario. And then start enhancing it with multisensory information, such as visual, audio, and so on. And then obviously deploy it to your customer and test it a few times with the actual end user and make some iterations there. So once you've done all this, you're ready to go and you are master in implementing haptics in your XR scenario. On behalf of the Presence project, I would like to thank you all and wish you very good luck with implementing our haptic technologies into your use cases.